a Boeing bonus special. So, Boeing aircraft have crashed a couple of times. And being me, I follow it just, you know, as any other armchair voyeurs have. Now, here's what I understand about the airline crashes for that specific Boeing, whatever it is, super duper. So, both the accidents were caused by part of the autopilot system, part of the onboard control systems. So, massive amounts of very intelligent software trying to make decisions off of a whole lot of sensors on board the plane. And it's not paying attention much to what the pilots or the crew are doing. It's paying attention to all the measurements coming from different instruments, airspeed, altitude, GPS location. So all these things are reconciled and looked at very hard in these real-time algorithms to say, okay, if the temperature is going up, it's going to change barometric pressure. So I should be able to see this elsewhere, and it's going to change air properties because we're in some very, very precise measurement areas. So what people have been talking about, the instrument on the plane, it's on the upper right side on that plane, by the pilot's cabin on the outside. It's called a Pitot tube. And that tube is a very precise airflow measurement thing with tiny little holes in it. And that's really all it is. It's looking at airflows, the suction being pulled in or the pressure being put on some tiny little orifices in that gauge. So if you've seen pictures of it, it's got a little wing on it, and behind that wing are some holes, or around that, and it's looking at a difference in pressures to make some very fast, very quick calculations on whether to put a wing up or down or how many degrees to go. So these are feedback mechanisms into specific control algorithms that supply information to other algorithms that look at other things to do. That software process is almost separate from all the hardware things going on. In a typical large development organization, they use something like a capability maturity model, which is one of the industry's most rigorous software development methods. So, and it is a methodology. You start at the beginning and you end with a product that meets very specific needs and requirements. So you go in and you develop all this software, and in real-time systems, you're building on something already there. So you're adding another feature or button. And the interactions of that feature or button are evaluated all through this capability maturity model process. There's different levels of organizational certification for these software processes. But basically, when you come into a working facility, say it's making plastic, and you're going to make some software change while that facility is running, you have to have confidence you're not going to blow the facility up. So that CMM process gives you some confidence in the software being able to plug it in. So real-time software. If I was going to do a BIOS update on your pacemaker, you would worry about that BIOS update. But you would probably be worried if I didn't understand the BIOS update, because you might not. So software at that level is a very precise, very controlled activity. What happened to that Boeing plane was a sensor might have gone bad. I don't know that we've proven that yet. I've seen people playing with these sensors and poking at them now that they've learned about them, but they've always been around. It's just a matter of the precision on the measurement side has gotten so much better, but the physics side, it's kind of still airflows over specific shapes. So I could go through that tube somewhere else, but all planes have them. So Somewhere in that process, a piece of software was installed in those planes that the pilot didn't know of. In both of those cases, from my understanding of the conversations, there was a button on their console somewhere, or maybe three buttons they had to push to disable that, to turn it off. And they probably, humans could have saved that plane, but it was the human controls were overridden by that software update. You go back and look a little bit more, other people, other pilots knew about that software. They had training about it. They might have known which button to push, and in their travels, they might have turned that off, not even thinking about, uh, you know, well, they should have. If they did something that critical in a plane, it would have been noted somewhere, or maybe not. It might be in records. We don't know the whole story behind this. So that is my take on it. The Boeing plane crash was an instrument we know has some reliability problems and issues. It has to be calibrated, it has to be certified. They get taken out, and there's a tag on there somewhere that says it was calibrated or certified. I would have put initials on that if I was in one of the labs it went by, saying it was calibrated or certified according to a very strict set of procedures, and my ability to watch the performance of that instrument and know it meets the criteria to do its performance. A calibration for a Pitot tube could take you a year to set up the facility to be able to do it. But once you have the facility, now it's old school and there's just a guy that does it, doesn't think too much about it. So, industry mislead, the liability for that software fault is so huge. I am kind of impressed that nobody talks to that anywhere, how that software release process was flawed, how that software release process very likely caused deaths. Some people are very aware of that software release process, how rigorous it has to be, and enforce those processes because my robots could kill somebody. My little wire guided electric vehicles could kill somebody, could kill a lot of somebody's. This is tons of materials, tons of robot, swinging around faster than a person can. You cannot make silly mistakes. So, yep. Uh, Boeing screwed up. There is no question. Boeing's looking for an answer. There is no question. What we're being presented for issues, I have question with. So that's my take. Software release problem, a due diligence issue in a process, and that is an engineer's evaluation, a software engineer's evaluation, because I've got a few titles. Peace out. Love and harmony. Keep it real.